So on the trig identities, after you copy down your learning goal on the one side, if you turn it over, there's a place for you to write those identities down. You'll notice it talks about the Pythagorean identities on the bottom of the sheet, as well as the tan, what tan theta equals, your different ratios there. Okay, so you can fill out these here, and down here put your Pythagorean identities, and then I'll show you where all those links are located on the unit circle. Okay, so get a chance to copy those down first. Okay, so here we go. We're going to fill out this guy here. All right, so tangent. Volunteer to tell me what tangent equals. Brittany. Sine theta over cos theta. Good. All right. How about cosecant? Go ahead, Jacob.
1 over sine theta.
1 over sine theta. Okay. How about secant? Yeah.
1 over cosine theta.
1 over cos theta. The reciprocal of cosine. And cotangent? Go ahead, Riley. Cos theta over sine theta. Which is also 1 over tangent theta. All right, what do we call those? What type of identities are those? Elizabeth? Those are reciprocal identities. Okay? Now, it helps to be able to identify things in a picture form. So we know that this length right here, we call this theta. We know that this length is cosine theta. That's from here to here. All right. We know that, so you may want to emphasize that because we're going to have another length there. We know that this length is
Sine theta.
Sine theta. And tangent theta is actually right here. Now there's multiple diagrams you can see on this. If you look online, you'll find a bunch of different ways of representing these. I find this to be the easiest, especially when explaining Pythagorean identities. So we have all those. Well, actually, you know what? Let's talk about some of these identities first. We know that cos squared plus sine squared is equal to
1.
Good. It's equal to 1, or 1 squared, right? In the unit circle, that length is 1. So a squared plus b squared equals c squared. So cos squared theta. Notice where you put the squared sign. You don't put it over next to the angle. Oh, sorry. Thank you. Cos squared theta plus sine squared theta is equal to 1, or 1 squared if you want to think of that. A squared plus b squared equals c squared. Okay? What was one of our other identities? Go ahead, Jacob.
1 plus tan squared theta equals secant squared theta.
Okay, 1 plus tan squared theta equals secant squared theta. Now, if that's the case, if that's an identity that deals with tangent, I tell you tangent is right here. Where's secant? Talk to your neighbor. You have the formula right here. All you have to do is find the right triangle. Talk to your neighbor. Where's secant located on that picture? Okay, the distance from the center point all the way out to where the little x is drawn, right there. Very good. This is secant. Okay. Remember, cosine and secant go together. Secant's the reciprocal of cosine. Notice they're the same. They're on the same axis there. It's another way to remember. But okay, so tan 1 squared plus tan squared is equal to secant squared. You have this right triangle right here. Okay. What's our last identity? Or our last Pythagorean identity? Good. Someone that hasn't participated. Have I called on you?
No.
Okay, well, we call you.
1 plus cotangent squared theta equals cosecant squared theta.
Good. 1 plus cotangent. Thank you, Julia. 1 plus cotangent squared theta is equal to secant, or cosecant squared theta. Okay. Everyone point out to your neighbor where cosecant and cotangent are then. Okay,
Reverse osmosis is the same.
let's see if we got it. 1 plus cotangent squared theta is equal to cosecant squared theta. Where is cotangent and cosecant? Jada, where's cotangent?
I'm guessing it's on the same line as tangent.
It's on the same line as tangent. Good. Cotangent theta.
Is that
That's from here to here.
we were close?
Okay? Nick, cosecant.
The cosecant is the length along the y-axis.
Good. Cosecant. That goes from here to here, the origin up to where it hits cotangent. So a squared plus b squared equals c squared. Okay? So we have our different pieces there. The picture, you guys, if you can remember the picture, these identities become a lot easier, and you're going to use these a lot. Okay? The Pythagorean identities become a lot easier if you can think of the picture. Okay? Yeah.
Does that mean cotangent is equal to root 3?
Does that mean
Cotangent theta, because since it's a right triangle and the base is 1, wouldn't that be 1 root 3 root 2?
Well, it'd have to be 30, 60, 90, right? You'd have to have the special right angles.
Yeah. That's
Okay. Any questions? All right, moving along here. I want you to now work on question 1 on page 612 and question 2 on page 613. You can work with your groupies there. Do it on the. No, it's not on that. It's on the. Just do it on the back of your sheet there. There you go. I'll put them up. I'll put them both up there for you guys. Okay, can I have your attention up here? Very good. Hey, simplify. When it says simplify, the goal is to get it down to one trig function if you can. You get as far down either that or a single number. Okay. So when I have secant theta and cotangent theta, Jacob, what do you think?
Oh, okay. So what you do is you simplify, or you like kind of expand those equations. For secant theta, you get 1 over cosine theta, and then for cotangent theta, you get cosine theta over sine theta.
Okay, let's pause for a minute. Everyone get that? We substitute that in for secant.
Yeah.
Okay, so it's another way of writing it.
And then they're multiplied together.
Very good. And you said this was?
Cosine theta over sine theta.
All right. Good. And then multiply, and you notice if you multiply, you can cross cancel there. Right? So cross cancel first. That guy cancels that one. We're left with 1 over sine theta. Brooks, pay attention.
Got you.
Okay, 1 over sine theta. What is 1 over sine theta? Megan?
Cosecant theta.
That's cosecant theta. Did you have a question?
Yeah.
Okay.
For the cotangent theta, how do you take that one over the other one?
Instead of 1 over tangent. This form, instead of 1 over tangent, you've just got to recognize that if you use this form, you can cancel cosine. So you pick the form that will best work. So if you put in 1 over tangent, that's not going to help you out much here, because you don't have cosine to cancel. Okay, in that case, you don't end up with a single trig function. When I say that, I mean like a single word: secant, cotangent, cosine, cosecant. That's what we're trying to get to, or a single number. Okay? How many think you got it? All right. Let's move on. Use Pythagorean identity to simplify each expression. 1 minus cos squared theta. Which Pythagorean identity are we using there? Go ahead, Sophie.
Cosine theta, or cosine squared theta plus sine squared theta equals 1.
Good. So if you think cosine squared theta plus sine squared theta equals 1. Okay, if we think of it in that form, we have the 1 in the cos. If I subtract cosine over to here, I get 1 minus cos squared theta equals sine squared theta. Okay, and that's by taking this and subtracting it to the other side. Right? So that equals that. That means 1 minus cos squared theta. Another way of writing that is sine squared theta. So the point of topic 3 is to get you prepared to solve equations. Okay, so in topic 4, when we get to topic 4, in topic 5 and we're dealing with different equations, what's going to happen is you're going to have to take this and plug that in so that you can actually solve an equation to figure out what the angle measures are for theta. Okay? So right now it's all about simplifying. So make sure you really pay close attention. That's why we spent 3 days on topic 3, is because it's so valuable when you apply it to topic 4 and 5. All right. Any questions on what we did there? Okay, the other identity, we have secant squared theta. That we know that 1 plus tan squared theta is equal to secant squared theta. If I take that, how do I get it to look like that? By Brooks?
Subtract 1.
Yeah, subtract 1 on both sides. So now I have tan squared theta is equal to secant squared theta minus 1. That's what we want. Those are the same. So our answer is tan squared theta. So if I had an equation and I saw this, I could plug tan squared in. Okay, and that could possibly help me out. Okay? Questions there? Go ahead, Megan.
Is the full linear answer?
Tan squared theta is my answer.
Oh,
Because this and they're the same thing.
yeah.
So this equals tan squared theta. Okay, last one. This right here, I get 1 plus cotangent squared theta equals cosecant squared theta. All right. Hey, if you're talking at your table right now, you need to be done talking, because maybe you get it, but the people that you're disrupting, they might not get it. The person to your right or to your left may have a C in this class or a D in this class, and they're struggling to keep their grade to where they want it to so they can move on to math analysis next year. Okay, you may have an A. Don't be the one that distracts them. All right? So this right here, if I want to manipulate it to make it look like that, go ahead, Brooks.
So we're gonna have to subtract cotangent squared from both sides, or yeah, and then we have to subtract cosecant squared theta from both sides.
Okay, so we get 1 equals cosecant squared theta minus cotangent squared theta.
And then we subtract cosecant squared theta from both sides.
All right, so we get 1 minus cosecant squared theta is equal to negative cotangent squared theta. All right, good job. So that equals negative cotangent. All right, it's a lot different. Okay? It's not necessarily an easy assignment. When you start today, some of you are going to look at it and go, I don't even know where to begin. And at that case, you start the problem, just get as far as you can, and you ask for help. Here's some guidelines that'll help you when dealing with simplifying. Okay? So put these down. First, actually, let me get a different sheet of paper here. Okay, first thing to do, eliminate fractions. Okay, some ways to do that. You could cross multiply. You can multiply by the common denominator. Okay, you can use substitution. Substitute. So if you have cosine over sine is cotangent. Okay, so use substitution. So if you need an example there, think of it that way, cosine over sine. You could substitute in cotangent. Okay, that eliminated a fraction then. Another thing you can do is factor out a greatest common factor. Okay. The third thing you can do is apply the properties. Just apply your properties. Anytime you see, well, let me write it down here first. Apply the properties or identities, I guess. Okay. Okay, for instance, if you see, I guess, 1 plus sine squared theta, or 1 minus sine squared theta. Let's use that one. Okay, you could plug in. What does that equal to? Yeah. Cosine squared theta. Good. You could plug in cos squared theta. Okay, so you're using substitution again. Okay, doing the same thing, but you just apply your properties. So look for those different things. If you see a 1 and you see a cotangent, you should be thinking, man, can I put cosecant in there, or cotangent squared? Can I put cosecant squared in there? Get used to using those properties. Okay? Your assignment today is that other sheet. All right, I'm sure there'll be questions. So the more of you that ask the same type of questions, the more examples we'll do. Okay? Here we go. All right, so off those problems you've started, what are the questions you have? Go ahead, Sophie. Number 6. Can we do first row first? Sorry, I should have been more specific. Let's go first row and then we'll go to number 6. Okay? Go ahead.
Number 2.
Number 2. All right. So number 2. Please tell me if I fall off the screen there. So tan theta over sine theta. So the first thing to do was, one of the things, if you have a fraction, get rid of that fraction. Okay? So one way to do that is, you could think of it like this. Tan theta divided by sine theta. In fact, that's how I'd write it. Okay? It didn't really get rid of the fraction, just rewrote it. But now we can say, well, we don't divide here. We can multiply by the reciprocal, right? So we can write that as tan theta times 1 over sine theta, which would seem counterproductive, except for we know what 1 over sine theta is. What is 1 over sine theta?
Cosecant.
It's cosecant theta. Now I'll tell you guys, if you memorize these, go to Quizlet, that Quizlet website. And look for, just type in Trig Identities flashcards, and there's all kinds of flashcards. You should really memorize these. It makes this math a lot easier if you can just go, oh yeah, 1 over sine is cosecant theta, versus actually having to look it up every time. I guess you'll eventually learn it that way too. Tangent, okay, if you leave it like this, you can't do anything, and we're not down to a single. So the problem students generally have with this assignment and doing simplifying in general is they're like, I don't know when to stop. I don't know what to do. I don't know even, what do you want me to do from here? I don't even know where to start. Okay, that's why I tried to give you the hints on get rid of fractions first. Okay, when you get to here, if you can't do anything with this, then you have to try to take each individual part and see if you can rewrite it. And we just had cosecant in a different form, and that didn't help us. However, if we look at this as tangent is what? Sine theta over cosine theta. Now, I purposefully had us actually replace sine theta with cosecant just so we could see that substitution. However, in this case, did it help us?
No.
No. It would be nice to actually have this back in that form. Okay? Tell your neighbor why it'd be better to have this in that form. Okay. So we get to there. I'm going to put it back in that form. Why did I do that?
So you can cross cancel into sines.
Yeah, I can cross cancel now. Hey, anytime you change forms also, you should really put parentheses. That way you know you've done that. Okay, you've substituted in. It's a minor thing. It didn't affect the math, but it allows you to cross cancel there. It's not cross multiplying, it's cross canceling, which is 1 over cos theta. And 1 over cos theta is what?
Secant theta.
It's secant theta. And we have now got down to our single function. Okay? And remember, those of you who get this, that's great. Don't get misled. They're not all that easy. And for those of you who are going, that wasn't even easy, you'll get there. Just keep paying attention. Okay? Other questions on the first row? Go ahead, Casey.
4.
Number 4. And taking a look at 4, we get tan theta times cos theta over sine theta. All right. So, if I'm going through this one, I first look at it as, well, what does tangent equal? Yeah.
Sine theta over cosine theta.
Sine theta over cosine theta. Now, anytime I see a tangent and a cosine next to each other, or a tangent and a sine next to each other, or a cotangent and a sine, or a cotangent and a cosine, I always think, am I able to cancel in some way? So I'm going to simplify this top part first. If you want to apply the same rules we did last time and just rewrite this whole thing like that, that's fine as well. Now you don't have a fraction. And if it makes you even feel any better, so that you're following the same guides every time you see that, multiplying by the reciprocal, that's great. Now I wouldn't do what we did last time and always change that right away, because on our last problem, when we changed it right away, it didn't help us. We had to change it back. So I would just wait until you finish with this portion. So I think of tan as sine over cosine. Times cos, remember that's over 1, and then times sine. Oops, excuse me, not times sine, times 1 over sine. There's that pencil thing I should be using again. 1 over sine. Okay? Jacob.
Now you can cross cancel.
Yeah, cross cancel those. Can I cancel those? Yeah, any top with any bottom. What's all that equal? Equals 1. Good question. Other questions? First 2 rows. We'll go first 2 rows now. We had number 6. Sophie? Okay. Number 6. Everyone take a look at number 6 there. Number 6 says sine theta plus cos theta quantity squared. All right. Well, there's a few ways to think about this. And this, by the way, this one does not come out to be a nice, pretty answer. All right. But I like to think of it when I see it like that, just so you don't get confused, and just say, well, that's just sine squared theta plus cos squared theta, because that's not what it is. We've got to multiply it. And some of you right away will come up with like, oh man, that's no fun. Okay, because that's where you do, for some of you call that FOIL. I like to think of it as distributive property. Whatever you want to call it, it may not be as much fun as you want there, right? So you get sine squared plus sine cos. Oops, sine times cos plus cos squared. Okay, so that one times that one's our sine squared, sine cos, and cos squared. Now I need 2 of these in here, right? So I forgot one right there. So that should be also a sine cos. doesn't matter what order you put it in. You could call it cos times sine. But anyway, I end up with sine squared theta plus, how many of these? 2
Why are there two?
sine theta cos theta plus cos squared theta. Yeah, the second one comes right
The
here.
inside last.
Yep.
Yeah.
Okay, any ideas from there? So we've now made that beautiful looking thing into this mess. Okay, let me circle those two. What does that equal?
Oh, that equals 1.
That's 1. That's a Pythagorean identity. Sine squared theta plus cos squared theta. Remember, you can add in any order, so I'm going to put those next to each other, plus the 2 sine theta cos theta. So this part right here equals 1. Okay, so I'm now with 1 plus 2 sine theta cos theta. I don't know what that is. All right?
PE.
Which is, that's as far as you're going. That's our answer.
So there was a 1.
Okay? All right. Any other questions on those first 2 rows?
7.
Have you tried 7 or are you just asking 7?
Yeah, I'm trying to.
Number 7?
Yeah,
All right. We'll go last one here. Number 7. All right, 7 is tan squared theta over sine squared theta. All right. So one way to think of it, once again, if you want to follow those same guidelines we've been doing before, write it like this. And I hope you start getting in the habit of saying I'm dividing by sine squared theta, which really means that's 1 over sine squared theta. Okay? When I flip it, I'm multiplying by the reciprocal, right? And that's tan squared theta. Oops. And another way to write tan squared is sine squared theta over cos squared theta. Okay, times 1 over sine squared theta. What happens? Those cancel. I'm left with 1 over cos squared theta, which is equal to
Secant squared theta.
secant squared theta.
Okay.
So,
Yep.
so that means all of the reciprocal identities, functions, they all apply even when like they're squared?
Even when they're squared. Correct. Yeah, your reciprocal identities are going to apply even when they're squared. Very good. All right. Good questions. Well done. Where it says verify it, you're given that. Cos theta over cotangent squared theta equals sine theta over tan theta. Okay? So your goal is to either make it say one of your Pythagorean identities. Like rework that whole thing until it actually says a Pythagorean identity, or until the 2 sides say the exact same thing. Okay, so I know that cos theta, what I did is I got rid of the fraction, multiplied both sides by cotangent squared theta. Okay, so I get sine times cotangent. Remember, cotangent squared theta is 1 over tan squared theta. Okay, which cancels that tan. And it leaves me with 1 over tan, which is cotangent. Okay, I then change cotangent to cosine over sine, and I cancel the 2 sines. So sine cancels sine. You think of that as sine over 1. And now I'm left with cosine equals cosine. If I divide both sides by cosine, I get 1 equals 1. Okay, you could have stopped at cosine equals cosine. That would have been fine as well. Okay, so your goal is to get each side equal to each other. Okay? Hey, it's not an easy assignment. You're going to be challenged. Make sure you work through each problem as much as you can.
Mr. McCoy.